The smart road represents a significant transition from the road merely perceived as a civil work, made of bitumen and concrete, to a smart, digital, interconnected, and intermodal road. With this in mind, the road turns into an active element within the user experience, communicating with vehicles through European standard protocols. The smart road consists of innovative technological elements, such as multi-protocol antennas, and an advanced software platform which can provide safety and infomobility services, by promptly and accurately exchanging messages with vehicles. The guidelines leading to the implementation of the smart road platform are: Internet of Things, to interface and integrate field devices; edge computing, through geographical distribution of the majority of the elaborations over local control rooms, providing the solution with resilience and scalability; big data-oriented approach, enabling the remote control room to manage any and all smart roads, and deliver advanced services to manage mobility. The following videos describe some of the services implemented from the point of view of smart road users, along the A91 road Roma Fiumicino. A stalled vehicle on the roadway represents an element of risk both due to the possible obstruction of the lane or the hazard passengers outside the vehicle get run over. In this use case, the platform notifies users of the presence of a stalled vehicle in the rest area after the bend, enabling them to adjust speed and the level of attention to the current emergency situation. In addition to reducing the risk of car accident, the early alert also enables users to evaluate the situation in advance and, in case, provide assistance. Roadside design, from ramps to crossings, can in some ways make it difficult to detect vehicles pulling in from side lanes which, due to their speed, or in poor visibility conditions, or drivers' carelessness, represent a hazard to road users. With the information provided by cars' onboard devices, the platform notifies users the approach of a non-clearly visible vehicle, potentially on collision course. In the clip, the user on the main road decides to slow down to let the incoming vehicle go first. The same information is dispatched to both users to maximize the chances to avoid collision. The quickly change in traffic conditions, due to the increasing volume of road transport, accompanied by the formation of queues, represents one of the main causes for the disturbance of the vehicular flow and the presence of risk situations. In this use case, the platform alerts road users to adverse traffic conditions so that they can change their driving approach. In situations of approaching a critical traffic condition, the user has time to adapt the driving behavior by reducing the speed, in the nearness of the traffic jam. The consequent constant speed adaptation of the individual vehicles approaching the traffic zone has a positive impact on the traffic flow. The presence of an operator working on the roadway, to report a critical situation to road users, represents an element of risk both for oncoming vehicles and for the possibility that the operator is overwhelmed. In the case of use, the platform notifies the user of the presence of the operator on the road, allowing him to adjust the speed and the level of attention to the emergency situation in progress. Although other vehicles may hide the presence of road operators, the user is promptly informed of his presence. The timely notification of the presence of operators at work substantially increases the safety of the operators themselves, representing an added value for those who work on the road.